Hello viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're going to talk about why building a NeillCylinder. So this is a part one. If the interest in this is good, I will make part two also. So let's dive deep into NeillCylinder. So what exactly is the problem that we need something like NeillCylinder? Well, humanity wants to grow and expand forever. If you are normal and natural and okay here, you want something like this. Basically, you want to achieve a lot of things and then you want your children to achieve greater things. And that's how it's supposed to go into perpetuity. So, okay, cool. Let's just say we start to do that. And we are doing surprisingly good in large scale time frame, not like, last 30, 40 years. Like compared to last 1500 years ago. So we're doing quite good. But here's the deal. There is an upper limit. Earth has a fixed surface area and it also has a thermodynamical limit. Because in principle, you can have a scenario where it's like everything is imported, all the waste is exported and you're just processing it, food and all that is coming from outside, and then you are dealing with things on the inside. Just people are there, almost like how you have in Trantor in the Foundation series of novels or the TV show. So but there is an upper limit of just human organism itself, simply because Earth is a ball of gas that radiates heat away and sun dumps heat into it. So there is an equilibrium, basically how much heat it can dump out without being too hot itself. So that gives you a certain limitation based on what sort of technological window you are calculating. Some people's estimate is tens of billion is the capacity of Earth's carrying capacity, and in some techno scenarios it can go up to 1 trillion maximum. But that's ludicrously upper limit, as in like, yeah, we should not be here if we are at like 1 trillion. Like we should have been expanded into whole solar system if we have 1 trillion. So and another aspect is Earth is too precious. Why like just convert the whole planet into something that we need, rather than just like, oh, this is the planet, this is our basically memory of our childhood. That's civilization wise. So Earth is too precious, and there is a dark side to that. Earth has too goddamn much history, as in, like, if humanity really wants to solve, let's say, global warming, let's just say CO2 pollution coming from our power generation, that can be solved tomorrow with solar. Not even battery won't be needed. All you have to do is create what we call intercontinental grid system, and HVDC technology is there. It's just that you can't. You have to cross so many countries and they will start firing missiles before you even got your first conversation. So there's too much history, and you're like, okay, what if we boom them? There's a good chance that you might become that history now somebody else wants to boom you. So it's a forever boom event where it's like, okay, your grandfathers are 10,000 generation ago did this, and that's why we are fighting. And then it's like 5,000 years ago you did this, now we are fighting. It's like, it's just too much mess. Like there is a point where it's just like, you desire a clean slate, as in like how you have that old cowboy movies. Like the idea is like, no, people just went somewhere else, like just middle of nowhere, just like, dude, give me a clean slate. And again, you can see that in all our cities also. Once the cities become too big, generally people give up on that. It's like, okay, let's create some another fresh start. We learned a lot from this, but let's create a better. It's like India has Delhi and New Delhi. That was the whole idea of it. And Mumbai and Navi Mumbai, the idea was like, Mumbai was like old, ancient, like it was pre-built, and not pre-built, I would say pre-grown, so to say. So they're like, okay, let's build Navi Mumbai with better transportation, with better infrastructure and all that. That's how we do. That's normal, natural. So we generally need a scenario where it's like, once we have learned enough, bro, fresh slate. Like, it's cool, it's awesome, it's GG, but Mark 1 is always garbage. We need Mark 2. At some point, you have to like throw everything away and go to Mark 2. Basically, like how in Iron Man 1 is like, he takes the first thing and it's like, throw this away, throw this away, throw this, start fresh. That's the whole point. And under known science, like, I'm not talking about like if this, then that, if graphene, if carbon nanotube. No, I'm talking about under known science and engineering. Let that be very clear. That's why I'm not talking about something like magical material. Under known science and under known engineering, it's easy, like surprisingly easy. Not economically, but it's easy. So there is a fundamental problem. Like you can't do much with like Earth simply because it has too much history, and you can't delete, and you do not even want to. Like inherently, you should not want to. So there are certain problems here. Now, we could not have even bothered to dream this if we did not have the ability to reduce the launch cost, which we successfully did. So it's almost like first mobile phone has hit the market. Now, like, okay, it was expensive, it's big. No. First mobile phone has hit the market. That means now people can think, what if you have a portable device that can do communication? The train has left the station. So at this point in time, we are still not there yet, but like we can see, like we can like almost see. So You can't do anything unless the price to orbit goes down low, as in like very low. Now how would we know that it has come down? Once people stop using kilograms. Like right now everybody talks about, like, per pound you have to pay this much, or per kilogram you have to pay this much money. Once we start to use, instead of kilogram, tons, and that's exactly how we do shipping right now. So if like you are talking about shipping, you generally do not say, okay, 1 kilogram of object. No, you will say like, tons. Shipping, plane freight prices might go up, but you get the point. So we need to ship massive load. Now here's the deal. Ideally, you will not want to ship everything. You just want to ship enough of a seed technology that it builds everything else. That's the whole holy grail, so to say. And SpaceX made this dream reality. Now, did we thought of making rockets reusable long ago? Yes. If you watch very long Discovery channels and history channels, there were a lot of shows. There were like a company that was building a rocket that had helicopter wings for landing. A lot of people were trying that, but SpaceX did something very surprisingly clever. I would not say like, whoa, genius, like clever. It was like, every mathematician, like people who know mathematics, will tell you, if you make a rocket that has to preserve propellant to come back, it will lose its payload capacity. So like, okay, what if I overbuild it? What if my requirement is 10 ton to low Earth orbit, but I build a rocket that throws 20 ton to Earth, and then I only put 10 tons on top of it and then use the rest for survival. It was like clever. It was like, people should have done that. And tada! And this unlocked the whole what you call mindset right now. It's like, there would be a penalty. Like law of physics is like, rocket equation cannot be cheated. You will have a penalty. It's like, okay, overbuild it. Overbuild it. Like even with Starship design, on principle, I don't think Starship could work as now. It's too goddamn heavy. So I think they may have to switch to basically still lithium aluminum alloy, or maybe Raptor 3 is ludicrously overpowered, which I doubt it. Mark 1 barely had like 5 to 6 ton to low Earth orbit. Mark 2 barely did like 15 to 20. Again, optimistic. Again, it's useless at this point in time. Mark 3, I don't see that much. But again, engine is lighter, so maybe. But again, that's the whole point. Like you overbuild a rocket. It's like, okay, what if the rocket was 300 ton to low Earth orbit? Cool, awesome, but it's too much. What if we made it reusable? Now it drops to 150 ton. Still awesome. So it was very clever, like very clever ideas, like overscale it. And Blue Origin is also doing it, which, mind you, Blue Origin is an older company than SpaceX. So they messed up. Like, ironically for Jeff Bezos, yeah, he like slow and messed up. Like, I think his effort was on Amazon at that point in time, but like that's slow. But again, he is slowly catching up. And Rocket Lab is also trying something unique where they're like, hey, what if you just reuse the first stage, but you do not have to throw away fairings, like, as in like fairing comes back at the same time. And again, it's a Mark II product. From Mark 1, a lot of improvement has been done. So it's like, and this will always happen. Like either you build it first or you build it better. Rocket Lab has the advantage of building it better. And again, this company's talk space is like, what if your stainless steel was utilized as a heat shield? Ta-da! So, and again, this is how they wanted to achieve stage 2 recycling. So, a lot of amazing things are happening. Now, what does that mean for this dream of a NeillCylinder? Well, cost will come down, meaning I can actually see a future where instead of kilograms, like, $1,000 per kilogram, we start to talking $1,000 per ton. That should happen. It could take time, I would say at least 30-40 years, but it could happen. Like I can see it, like there's a vision there. So cost will come down, and high cadence, meaning you pick up a phone, it's like, bro, I need to send the satellite into orbit. They're like, yeah, the next flight is 3 hours from now, can you manage it? That's what we should have. Again, I don't think it will be 3 hours, but you get the point. And we are actually getting close. Like, I'm not even joking, a Department of Space actually has a requirement that they should be able to yeet a satellite into orbit in 24 hours from phone call. They are almost reaching it. So that's the whole point. And higher the competition leads to lower price and quality, meaning if you only had SpaceX, that's a bad thing. That's a really bad thing. You really want somebody to like, okay, SpaceX built Starship. What if we Control C and Control V it in China? And then somebody in China has brain and it's like, okay, this is cool, awesome. What if we just throw away the stainless steel, put lithium aluminum alloy? What if we, instead of having heat ties that are weirdly attached to it, what if we just glue it and we create an automated system of replacing it if it cracks? We have the technology. We can do it. So then you're like, what the hell? How the heck they have 200 ton to low Earth orbit, which is cheaper, reliable, and safer? So you want that. You always want multiple competition. You want Rocket Lab to try something different. You want Stoke Space to try something different. This is awesome. You want a Blue Origin to try something more conventional. This is good, desirable, allows the price to come down, allows the quality to go up. This is awesome. Like we can see, like we can easily see by 2050s, basically space station in low Earth orbit would be like, bruh, we have it. Like if you have money, just build it, just go. So first hurdle that was like, okay, we could not even dream about it, that has been sorted. Now we come to the second hurdle, ISRU. We can't ship everything from Earth. Even if the tonnage goes down, you do not like the idea of like, okay, let's ship 10,000 ton of material, which will be nothing. Like we have to ship gigatons of material if you really want to make some big puppies. So that can't be done. Now, we want to send a seed technology. That's why we do want tonnage. But second stage would be building things in space from materials on the moon. Now, why exactly moon? Well, here's the asteroids are a bit far. Moon is very close, like 3 days close. So it's very close. And moon has almost ironically well mixture. It's almost like somebody put material cache for humanity to grow. It's like we're gonna have humanity here. Once they become smart enough, they can jump here and then they can expand somewhere else. Like it would be very easy. Imagine if we did not have moon, we would be kaput. If we were growing in Mars and we had like those tiny moons, it would be better than nothing. But like moon is like, I got you, fam. Like I got you. Take gigatons away from me, it does not even matter. So moon has low gravity, meaning you can land easily, you can take off easily. Heck, you do not even need to have a rocket to take off. You can just yeet things into space. Spin launch will actually work in moon. And if you do not want that spin problem, what if you just have a coil gun? You can do that also. So surprisingly low gravity. And here's it has gravity, which is the desirable thing, because again, if you are doing a lot of processes like let's say molten metal separation, you want separation that sometimes rely on density. That does require gravity. Again, lower gravity is still better than no gravity. So it does work. So that's a really good thing for us. Like things work. It's a bit different, but it works. That's a really good thing. And it's much easier to launch from moon, so to say. And it has a vacuum. That is super awesome. That's not like a hassle on Mars where it's like, okay, it is almost like partial atmosphere, almost like what is 15% of 1 psi. Less than 1 psi is the atmospheric pressure. It's weirdly stupid, as in like it's not vacuum enough where it's just like, okay, let's just put solar panel and don't worry about it. So like on moon, unless you have a rocket landing next to it, you do not have to worry about it. On Mars, you have to worry about it. You have sandstorms that can last for freaking year. So not year, I think months, but yeah, it's bad. So having vacuum removes all that hassle, meaning you do not have to worry about weather, meaning all your things last much longer. And if you have energy collecting, which again, solar would be the best for that, you don't have to worry about it. It's like you put solar works 24 into 15. You do not have to worry about it. Like for 24 into 15, and again, you might have like 3 giant solar farm, like so one of them is always in full sun, another is like partial sun, 2 would be on partial sun, 1 would be always in full. So and there are certain places where you have 24 into 7 sun. So that's also an option. So there's a lot of amazing things. And we are working on that technology right now. Like if you really want to cook your brain, I would urge you to watch the videos I'm linked down below. The third video, it is 2 engineers and scientists talking about how to actually get metals out of these puppies, as in regolith. How would you go about it? Like, okay, we have stuff. What now? What can you actually do given the constraints of the reality? Well, the idea is you have a tube and you fire pulse laser. Why? You are doing what we call a vacuum pyrolysis, as in cook the material. But here's the, if you have vacuum, as in 10 to the minus 10, I think, Tor, if you have that sort of vacuum, and if you heat that puppy up to, let's say, 1500 to 1600 degrees Celsius, it disassociates, oxygen disassociates, and metal condenses into different state, meaning you can easily separate it out. And other temperatures can be achieved, which for other metal extraction can be done. So, single step. Done. Go home. And there are a lot of other options also. People are working on it. So we have people right now working on it. And be mindful, America also has planned for this. China has planned for it. Like, I'm not joking. China has a rover right now that's supposed to land and has a solar furnace to do miniature experiments right now. So again, it's not launched yet, if I'm not mistaken. It's like they're gonna do this. So we are working on it, and that's the next step. The idea is you're gonna send enough things from Earth to moon to build a moon up. Once moon becomes self-sufficient, and I mean in everything, then moon will start to become an industrial base. That will allow you to have tons of material. Like, who cares? Like, oh, you want steel, how many? 10 gigaton, take it and go. Like, okay, if this is your shipment, take it and go. Ain't nobody got time for that. So that is ISRU. It can be done. Moon is the best for us simply because it's very close and it has enough sunlight. best of the everything. So really good scenario. And again, this is like they're figuring out how do you melt it without having thermal stress inbuilt into it so it does not crack. They're solving it. It's like you melt it once, then you remelt it. I did not really remelting it would help that much, but apparently it does. So now you can make a bricks out of it. That's how we'll start. We'll making bricks out of it, and brick by brick we'll build other things. So, and again, all it requires is mirrors and all that, solar panels and all that. So Mark 1, all you are sending is foundation technology. After you have foundation technology, then you will build the construction technology. Once you have construction, then you keep rebuilding the foundation technology on moon itself rather than transporting. So all you are transporting is humans from Earth to moon. So this is amazing, and a lot of research and work is being done. So you can see a future where humanity is able to have a foothold on moon, which is self-sufficient. Of course, they will import coffees and all that, but they will be like, we good, we got this, we good. Now, who are the pioneers of this? Well, here's the deal. Planets have pre-existing rule. That's the fundamental realization of Dr. O'Neill, Gerald K. O'Neill. And he's a physicist. In 1969, he created a small think tank with all his students and all that. It's like, okay, assume what we know of science right now. This is Apollo era. We know things about it. There is optimism. It's like, assume you have that. Now, what would be the best way to have boatload of people in this space? Like, how would a civilization work? As in, like, it's a spacefaring civilization. What would be the best civilization? Be mindful, science fiction has existed before this, and almost all science fiction is like, okay, what if we have landed on the planet and all that? So he did the math, the actual math, and the output is that you have too many pre-existing rules. Meaning, if you want the gravity of Venus and the daytime of Mars, you can't. You can't. Like, of course, like if you really try to do something, maybe, but fundamentally speaking, like, just this is 1960s technology. Even today's technology, you have a gravity fixed, you have day-night cycle fixed, you have atmosphere composition fixed. You can't do anything about it. However, he figured out planet's surface is not that desirable unless it matches Earth. Go YOLO. But if it does not matching Earth, it's like it's not desirable. So what if you made a cylinder, O'Neill cylinder? So idea is that you can have much less material consumption. As in, like, let's just say you consumed 100-kilometer asteroid. How much surface area you can build out of it? Bonkers. The answer was bonkers. Like, it does not make sense to do anything else. Like, you can have trillions of humans on the resource cost of few big asteroids, big air ones, big puppies. So that's the whole point. Like, fundamentally, and you control every vector that is important. As in, you want like exactly right amount of gravity. Or let's say you are doing a heavy industrial process that relies on gravity, you can actually increase the gravity. You're like, hey, instead of 9.8 meter per second square, like, okay, what if you had 10 meter per second square? GG. Or you can keep changing it. So that's up to you. You're like, okay, for old people, you may want to have a scenario where habitats are much lower and still enough that things work, but like not high, stressful enough where your joints hurts and all that. Those things can be done. You can have a scenario where atmosphere composition is very precisely tailored, temperature is precisely tailored, day-night cycle is precisely tailored. So a lot of variables become easily doable and no magic technology required. No magic needed. Like, they were building big structure. I was like, okay, how can you build a structure that big? Yeah, steel. Steel has the material strength for it. And be mindful, we did try that. Like, we actually had Saturn V upper stage that was rebuilt as a Skylab, I think. And they spun it and it worked. Like, we know it will work. It's done, sorted, done technology. So that's the pioneer. And again, Jeff Bezos also wants this, and a lot of people who really understands like the reality of the scenarios. Like, it sounds cool. It's like, we're gonna land on the Mars, we're gonna terraform the Mars. Yeah, that's a 400-year process. 50 years, take it and go. Like, if you spend 400 years building a O'Neill cylinder, how much surface area and quality of life you will have versus how much quality of life you will have on Mars? It's not even comparable. And again, that's assuming best case scenario that human body is tolerant to gravity. There are some biologists who are saying that we can't actually, unless, like, we have sex in zero gravity, have children in zero gravity, we do not know that our body can handle zero G. Like, we are only exposed to it like 6 months, 1 year maximum. That's nothing. And especially in gestation period. So there could be a scenario that lower gravity is just like, no, human body cannot grow in the low. Like, again, once you're pre-built, like solid, GG, go YOLO. But it's not something that you can be exposed to when you are growing. So that could be a worst case scenario. In that time, this will still work. At that time, you're like, you can send robots to Mars, but you can't live there. Again, then you have to do a lot of genetic engineering, all that, or just build O'Neill cylinders. Have fun. So that's the whole point of it. Fundamentally, given assuming the worst case, I'm like, okay, what about radiation? Let's have like so much. It only requires 10-meter thick soil. If you have 10-meter thick soil in this cylinder habitats, it will have lower radiation than what you exposed to in the surface of Earth. Be mindful, Earth also has radioactive stuff at the core and cosmic radiation from the top. It's not that radiation free. So you can make this surprisingly radiation free. It is doable. So all science like radiation, temperature, pressure, all those things. They're like, what if this happened, that happened? We have submarines that can handle like deep sea pressure. This is easy. The PSI difference is 15. We build submarines that can handle 100 PSI or more than that. So easy peasy, take it and go. And be mindful, Apollo mission actually had a lunar module that was so flimsy. If astronaut was very angry and they punched one of the right places, they will punch through it. Not even joking, they will punch through it. It was that thin in certain places. 15 PSI is not that much. Now, this is the core concept of why philosophically we have to do it. Well, this is a great filter because let's just say you have Earth. Earth has two civilizations into it. And one civilization is what we have way too many of them, bitchers and moaners. It's like we have problems and this and that. And it's like, okay, solve it. The end. And people who are way too attached to the past and like, in this and that is like, basically anti-natalist kind of scenario. There's like they're stuck in the like, okay, there is problem, solve it now, solve it. And you have a civilization that sees planet as a cradle, as in like this is a starting point, like this is humanity started from here, this is not our end point, like this is start, we can go wherever we are. Now again, I cannot guarantee you like whether it will succeed or not, but likelihood based on time, like if I have 10 clones of this, I can guarantee you at least in 5 or 6 of them, the part that is willing to expand will survive. And I can guarantee you it in all of them where people are stuck in bitching and moaning stage will perish eventually. Because again, nature will kaput you. Like nature does not care. Nature does not care about anything. Like nature is cruel on a level that humanity cannot even imagine. I hate basically Animal Planets and all that. They had like, codifiers like, oh, this is planet and this. Like, no. You are like filtering too much. Like if you really want to give yourself nightmares, look what one ant colony does to another ant colony. Good luck. You will look like a teenager throwing temper tantrum. And time is not kind. Let that be very clear. Time does not care. Time just, we had like a civilization that had like houses made out of gold. Time is like, I do not care. Shift delete. Time does not give a yuff. So fundamentally, so you have to think like Earth as a cradle, as a starting point of star-spanning civilization. Or you're going to be kaput here. Because again, planet will be kaput. One way or the another, it will be kaput. It's almost like a living entity. It will go kaput. How? That's the part that we have to figure out. When is the part, is that our deadline? As in, what if an asteroid just makes kaput with it? That's a big problem. What if the Earth's magnetic core is just like, yeah, I'm out, I'm quitting? That's a kaput event. What if some biological organism can grow faster than we can handle it? Kaput. And yes, there is a chirality event that can happen that could do that. I hope that's a fake. I hope that never happens, but that could get out of hand way too quickly, which could do almost like a first great oxygenation event. So there are a lot of scenarios where it will happen. It's just that we do not know how. Or a supermassive volcano just says, today is my day. So reality is, rock will eventually figure out, like this planet Earth will figure out. It will be no different than Mars at some point in time. And there will be a time when sun just says, achoo, and kaboom. The sun expands and everything gets kaboomed anywhere. So it will happen. It's a fixed thing on geological time frame. If we are not barely safe, and cosmic time frame is like we do not even exist. So that's the whole point. Time will erase everything. The only thing you have is fighting to keep time alive. Basically, our ancestors started from here. We do not have problem compared to this one. So that's up to us. Like we can take this as a starting point and hope that our children can go even further than us. But to do that, we have to lay the foundation of that. And I like this statement. This is the most amazing statement I've seen in basically Doctor Who. Great men are forged in fire. It's the privilege of lesser men to light the flame. And I have to say, like, if you can watch the Jeff Bezos' statement, he's very clear about that. It's like, I'm not going to be alive when this O'Neill cylinders can be made, but I hope that I build this sort of technology that allows that. Now, can we do Mars landing while Elon Musk is alive? Yes. A self-sustaining Mars colony? No. That's not happening. Heck, because again, we have to do moon first. And now again, if we crack moon and like a lot of exponential technological growth happens, which we do, computers went from not existing to in my pocket in less than 30 years. It could happen, but likelihood is a bit low. So this is a great filter. Like there could be millions of civilization, millions of planets of them, and they just all get kaput simply because they have way too many people of bitchers and moaners. Maybe that's why the universe is quiet. It's like nobody bothered to, we have problems here. Why you want to go to space? And we are so lucky we have a material depot orbiting us. Like, bro, come on. Moon is saying, bro, come on, man. Come on. So this was a presentation on NeillCylinder. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.